Hi there, my name is Sam Chapman, and this is my demo video for the Data Engineering Capstone Project through Northwestern University's School of Professional Studies. In this project, I leverage Fivetran's fully managed connectors to build a functioning ELT pipeline. The sources are a cloud function deployed in GCP, a AWS S3 bucket, and a GSheet, and the destination is a Snowflake data warehouse. The purpose is to simulate a normal workflow for using Fivetran to build out a fully managed ELT pipeline, as well as highlight some of the features built into Fivetran. Utilizing Fivetran as opposed to building your own data connectors provides great value in a number of ways, including handling the technical side of building and deploying software to connect to databases or applications, as well as letting Fivetran deal with things that can throw a wrench into an ETL pipeline, such as API changes, schema changes, or new object creations. Additionally, Fivetran processors provide logic on data type inference, deduplication, and proper state setting for pagination in case the batch is disrupted. In other words, Fivetran knows where the last sync left off and has logic to try the batch again in case of any sort of error. With that, let's hop into the demo. I'll first show and explain my Google Cloud function, show Fivetran's UI in the Snowflake connector, and then show a few great features in Fivetran to work with the pipeline. First, the Google Cloud function. This Python function is calling the USGS API to pull river flow data for a popular rafting spot on the Colorado River near Kremlin, Colorado, commonly referred to as the Upper Colorado. The data we are looking for is cubic feet per second, or CFS, which provides the river flow. The cloud function calls the USGS API, pulls out the CFS information, and then sends off a Flask response. The code is deployed in GCP, but just as easily could have been deployed in any other cloud function application. Now that we have the cloud function created, we can hop into Fivetran's UI and set up some connectors. First, we set up Snowflake, which is insanely easy to do. In order to set up a Snowflake connector, you have to provide the information here, and Fivetran provides the documentation on how to do this. Again, all very straightforward, and once this is connected, then Fivetran will have a link between the Fivetran UI and Snowflake destination. I've already connected this, so for the sake of the demo, I'm going to skip this. Next, I'm going to set up a cloud function connector. This is also very straightforward. So here's the information in order to create a Google Cloud function connector. I'll need the destination schema, the function trigger, and then the secrets to access the function. Very basic and pretty straightforward to do. Again, I already have this connector created, so I'll skip that for this demo. So now that we have these two connectors set up, we can look at the configuration of the cloud function connector. Specifically, we're looking at the sync frequency. Since the function is built to call the USGS API every time the cloud function runs, this will determine the frequency we are pulling data. In other words, if it is set to 30 minutes, then we will get CFS data in 30-minute intervals. I also pulled some historical data and dumped it into an S3 bucket and GSheet to also show how easy it is to set up connectors with these type of files. Combining data from many different sources, some of them with static historical data, is a common practice, so I wanted to highlight how Fivetran plays a role in this process. The connectors are very easy to set up, and the data is now loaded into Snowflake once the connectors are set up. So here's the GSheets connector. Again, very basic to set up. I'll walk through how I did it. Give it a sec to load. Great. So very basic information in order to get GSheets hooked up. Again, really straightforward on how to do this, and Fivetran provides great documentation on how to do it. The other thing I had to set up, again, was that S3 bucket. And again, another very similar basic connection. The Fivetran makes it very easy to do. Destination schema, destination table, the bucket, and the folder path. Great. So now that those are all connected, I can hop into Snowflake and see all the databases that have been created. Note that I have 3 different databases. I actually have more than that since I've created some with some additional demos, but for the sake of this demo, I'm going to focus on just the 3 ones I created. My Google Cloud function, my S3 bucket, S3 Kremlin, and then also my GSheets, which is going to be right here. These are the 3 databases I just created through Fivetran's UI. However, now that I have 3 different databases, I want to join them together into one table with all the data across time. I can leverage Fivetran's transformation layer to do this. Fivetran is basically the scheduler, which runs the SQL query in Snowflake every time new data is loaded from my Google Cloud function. The end result of this query is a newly created table with the historical data from S3 and GSheets, as well as my new cloud function data. The newly created table updates every time I pull data from the cloud function, so my data is always up to date. That's where I selected this right here, new data, and I said every time the trigger table Google Cloud function, upper C, has new data, it'll run this SQL query. Finally, I wanted to highlight some of the unique features of using Fivetran's REST API. Fivetran allows users to interact with its services through REST API and includes things like getting connector details, setting up or modifying a connector, modifying the schema of a connector, and for our use case, initiating a sync. For the sake of this demo, I decided to show how a post request can kick off the Google Cloud Function sync. Again, if you remember in the Fivetran UI, I had set the sync frequency to 30 minutes. So if I wanted to run a sync in between that time to pull new data, this is how I could do it. So running the post, we see that we have a code, success. The sync has been successfully triggered for connector. So now if I go back into my Fivetran UI and go back to the Google Cloud function, I see that it is now syncing data and has kicked off a sync because of that post request. This is useful if I wanted to create a unique sync schedule that Fivetran can't handle, or if I wanted to build a pipeline built off of more complex processes. Once these complex processes finished, I could then have them send off the post request to initiate the sync. The point is, Fivetran's REST API provides increased functionality for more complex usage of the product. So that concludes the presentation and the demo. Fivetran was used to build a fully functioning pipeline with a few different sources and Snowflake as a destination in less than 5 minutes. A cloud function was used to simulate a source. However, this is one of the more complex ways to use Fivetran, as there are hundreds of pre-built connectors for applications, databases, webhooks, and file upload services. The application connectors in particular are very useful and provide users with a fully managed pre-built connector for applications such as Salesforce, Zendesk, Google Analytics, and NetSuite, to name a few. I hope this demo helps shed some light on cloud functions, as well as how easy it is to set up a fully managed working ELT pipeline using Fivetran, so you can focus on getting actionable insights faster as opposed to managing your ELT pipeline. Thank you.